Hey everybody, Mrs. Bixler here, and we are starting Unit 4. Woo woo! So Unit 4 is all about trigonometry, and trigonometry is the study of triangles, usually right triangles. And we're going to focus mostly on right triangles until the end, so get ready. So I wanted to first talk about two special right triangles. Now, obviously, there are an infinite number of right triangles that we could have, but two of them are really special. So one is called a 45-45-90 triangle, and the other one is called a 30-60-90 triangle. I want you to think really hard why they have those names. So the first one, the 45-45-90 triangle, is named after John 45-45-90, and the 30-60-90 triangle is named after Margaret 30-60 von 90. So make sure that you write that down. I'm going to be quizzing you on that later. Just kidding. Okay, the reason why it's a 45-45-90 triangle, you smart, you figured it out. So we know that we've got a right angle here. That is our 90 for both of them. In a 45-45-90 triangle, it's a nice little isosceles triangle here. So our two angles are going to be 45. And then in a 30-60-90, also these stand for the angle measurements. So John 45-45-90 and Margaret, was that her name? Margaret 30-60 von 90. They might exist, but I don't know if they have anything to do with naming these special right triangles. All right, so those are the two right triangles we're going to talk about today. So the first one is a 45-45-90 triangle. So I want you right now to pause the video and I want you to fill in these blank spots. So I want you to tell me what this guy would be and what this guy would be, just sort of using your knowledge of right triangles. Go. All right, we're back. So hopefully you figured out that this guy was also 3 because it's an isosceles triangle, right? If angles, then sides. And then you knew, because of the Pythagorean theorem, that we had 3 squared plus 3 squared equals c squared. And so then our c was going to be 3 root 2. Awesome. All right, moving on. I want you to pause the video again and fill in these blanks. So I want you to solve for this guy, and I want you to solve for this guy and this guy. Go. All right, we're back. So these are actually really easy to solve for, these legs, right? So I know that this guy is also going to be 5. And then same is true over here for this one. So I know that we've got a side length 12, so the other side length is also going to be 12. The harder part, I guess, was finding that missing side. So you know, because of the Pythagorean theorem, you know that a squared plus b squared equals c squared. So then our missing side length is 5 root 2 and 12 root 2. Interesting. So do we see a pattern emerging? If I look back here, I've got 3, 3, 3 root 2. 5, 5, 5 root 2, and then 12, 12, 12 root 2. So, there is a pattern. And here's the general pattern. For 45-45-90 triangles, if this side length is my x, this guy is also going to be my x. So the two legs of my triangle are both going to be x, and then my hypotenuse is going to be x root 2. Memorize this. X, x, x root 2. X, x, x root 2. X, x, x root 2. And if you're going like this, like while you're doing your homework or studying or taking a test or a quiz, no judgment. All right. So now I want you to pause the video and fill in these blanks. All right, we're back. So you've got a 45-45-90 triangle. Hopefully you knew right away this guy was 6. Snooze, 6 root 2. Amazing. Moving on. Pause the video. Do this one. All right, so you've got a base of 2, and we know that this guy, sorry, root 2, so we know that the other leg is also going to be root 2, and then this has to be 2. And the way you get that is you know that if this is your x and this is your x, this has to be x root 2. So if x is root 2, then this is just root 2 times root 2. We know root 2 times root 2 is root 4, which is dose. Awesome. All right, now we're going to talk about the second kind of special right triangle. And this is a 30-60-90 right triangle. So what I'm going to do here is, let me just scooch myself over. Okay, what I'm going to do here is I'm going to double this triangle. So instead of having it be like a 30-60-90, I'm just going to double it for the sake of this explanation. So my doubling of it looks something like this. It's not perfect, but it's all right. So then what happens here is this angle becomes 60 degrees, And so I know, because I know a lot about triangles, if these two angles are 60 degrees, then I know this guy also has to be 60 degrees. So this now turns into an equilateral triangle. So when I double this 30, 60, 90 triangle, I get a bigger equilateral triangle. Cool? So I know that this base then has to be 6 units long. If that base is 6 units long, because this little guy's 3, right? We doubled it. Then I know that this side length also has to be 6 units long. So now I want you to think about, well, if those are both 6 units, sorry, if the base is 3 units long and that hypotenuse is 6 units long, I want you to pause the video and try and figure out then what this height would be. Okay, we're back. So hopefully you figured out that we've got a little Pythagorean theorem here. So I've got my height here. So height squared plus 3 squared equals 6 squared, so 36. And then subtract, my h squared is going to be 27, which means my height is going to be 3 root 3. So here, can you see some sort of pattern? If I'm just looking at my 30, 60, 90 triangle right here, I've got a nice little x, I've got twice x, and then I've got x root 3. So let's scooch on to get this down. So in a 30, 60, 90 triangle, and this is really important, across from the 30, so across from the smallest angle is going to be our smallest side, which is x. Across from our largest angle, which is 90 degrees, is going to be our largest side, which is going to be 2x. And then the height across from the 60 is going to be x root 3. Memorize it. X, 2x, x root 3. X, 2x, x root 3. The way I kind of helps me remember is I know that like this is 1, 2, 3. That's a nice little way to remember. But remember, the longest side is always going to be 2x, which is opposite the right angle. Okay, so now I want you to pause the video and fill in these missing spots. Okay, we're back. So hopefully you figured out that this was your x root 3 side. So then it should have been really easy what your x is, 4, and what your 2x is, 8. Amazing. Okay, let's try the next one. All right, here we go. Pause the video. And we're back. So hopefully you figured out here that this side was 2x. So this made it a little easy. Your x is going to be 5, and then your x root 3 is going to be 5 root 3. Fantastic. So let's do a quick little recap in a nutshell. See, that's a person in a nutshell. Make sure that you feel really good about this. Pause the video and we'll come right back. All right, so you should feel really good and you should have this in your notes. So 45, 45, 90 is x, x, x root 2, and a 30, 60, 90 is x, 2x, x root 3. Before we move on to some problems that involve either one of those mixed together, I wanted to make sure that we did a little throwback here. This is a guy doing the Running Man, which is one of my favorite dance moves. Pause the video and answer these 5 problems. Okay, we're back. So hopefully you felt really good about these. The first one's going to be CBS. The second one is 25 root 6. The next one is 5 root 10. The next one is 10. And then the last one is 10 root 2. You should feel really, really good about these. If you don't, go back and just review some of that stuff that we've done in previous chapters in terms of simplifying radicals and working with radicals. And then we're going to do another little throwback, a little MC Hammer throwback. So I want you to pause the video and simplify each one of these 3. Okay, we're back. So hopefully this first one, you got that it was 5 root 2. So that 25 over 5, those guys reduce. You don't touch the root 2. All right, the next one, that 5 over 10 reduces, and you don't touch the root 3. So it just becomes 1 root 3 over 2. And then this last one, actually nothing happens to this guy. So this is the final answer because you can't simplify 12 over 5. All right, fab. So let's do 2 more problems. I want you to pause the video and try and solve for the missing numbers here. All right, we're back. So hopefully you recognize that this was a 30, 60, 90. Whoops, I said 30, 60, 90. 45, 45, 90 triangle. So you know that the relationship is x, x, x root 2. So in this case, this side length is going to be my x root 2. So you've got to do a little work there to figure out what your x is going to be. So what I do here is I just solve for my x in that case. So hopefully right here, you figured out that both of these side lengths are going to be 5 root 2. All right, last problem. Here we go. Pause the video and then come back. Okay, we're back. So hopefully you figured out that this is a 30, 60, 90 triangle. And the side length that you were given here, this is going to be your x root 3. So you have to do a little work in order to simplify this one. And so hopefully you figured out that your x side length is 3 root 3. And then your 2x side length is going to be twice that, so 6 root 3. All right, so hopefully this all made sense. Go ahead and tackle the homework, and I'll see you soon. Thanks.